So here is the link. Hope white screen is visible to you.
Yes, sir.
Yes, sir.
Right now,
Yes,
see,
sir.
I can use this much part of the screen. Right, this is the upper end where I am writing the dot. This is another upper end. These are the lower ends. I can use area between these four dots, the rectangle formed by these four dots. Okay, so what I'll do now, I will divide the page in two parts. One on the left side, I'll start with the left side page, and one on the right side. Okay, so let me start. Again, we have these different colors, right? The colors which are visible, I will try to use them only. Okay, I think all colors are not visible. Whether this white color, then this black color is okay, but again this black color not no difference from this black color. Okay, so let me use them. So let me start with the recap that already we studied yesterday. Hope this is visible. If it is not visible, you can zoom your screen of the mobile, and if it is laptop or PC, I think it is visible to you. Okay, so recap. What we studied? We studied Maclaurin's theorem. Huh? Maclaurin's theorem. What is Maclaurin's theorem? Suppose f of x is a function of x which can be expanded in ascending powers of x, and expansion is differentiable as well as continuous term by term, then f of x may be written as f of x equal to f of 0 plus x f dash of 0 plus x square divided by 2 factorial f double dash of 0 and so on. Okay. Then we studied a few examples of this type. Type number 1, we solved few examples of the Maclaurin's theorem. And then we started with the type number 2. Type number 2 was like this. Type 2, we started with the use of standard expansion. Okay. Again, inside use of standard expansion, we understood what is the lowest degree term. Hope you remember lowest degree term. This concept we understood. What the concept? The concept was like this. Suppose we have z equal to say x minus x square plus x cube. Right. So lowest degree term is x here. And if you want to find lowest degree term in z raised to n, that is equal to lowest degree term in z and whole raised to whatever the power is n. Okay. Then so in this case, the lowest degree term in z is x, so it will be x raised to n. X raised to n. Okay. Right. Whereas suppose I have a different example. Say I have this example z equal to 1 minus x plus x square. What is lowest degree term here? 1. If we take z
1.
raised to say 10, what will be the lowest degree term? 1 raised to 10, and that is equal to 1. Okay, we understood all these things very well. Okay, then now we have to go through few examples, right? So again, we are using the Maclaurin statement, and we'll develop few formulas, and at the end we'll write the formulas. I think we started with the even function also, right? Now, so we started with the even function. The definition was like this: a function is said to be even if midpoint. Already we have written this. Midpoint of the interval is x equal to 0, and the second condition f of minus x should be equal to f of x. Then the function is said to be even function. We have written the examples also. The examples were cos x. Okay, then odd degree terms, sorry, even degree terms, x square, x raised to 4, x raised to 6, and so on. Then mod x, right? These are the even functions. Then constant
Constant
number function, which is defined by constant number, they are also even functions. Okay. Then we understood how the graph of this even function is. So the graph is like this. For example, suppose let me draw the graph of y equal to x square. This is parabola, and the parabola is like this. Okay. Again, this is y-axis, this is x-axis. So what we understood, symmetric about y-axis. Right? All even functions, they are symmetric about y-axis. That is what we understood. Okay. Okay. We'll go through the next part. Write down. Write with me. Odd function. Now write with me. Right. Odd function. That a function f of y equal to f of x, or you just write f of x, no problem. A function y equal to f of x is said to be odd if, right, one, midpoint of interval is x equal to 0, right? Second condition, f of minus x equal to, yes, what is f of minus x? Minus of f of x, right? Then write examples, right? 1, f of x equal to sine x, right? We know this about the sine x. Proof is like this. Proof is again not required, but better to understand it. Sine of minus x. So what is sine of minus x? Minus of sine x. That is minus of f of x. Right? This is what the definition is. Right. Second example. Right. Next. Odd power terms. Write with me. Odd power terms. That is x, x cube, x raised to 5, and so on. Odd power terms are odd functions. Okay, then on the next page, let me change the page. Have you written all these things very well?
Yes, sir.
Have you written?
Yes, sir.
Okay, I'll write this as page number 1 only. Okay, now let me change the page. Yes, you are not audible. Okay, so written. Y equal to, for example, suppose we have x cube. So how is the graph of y equal to x cube? It is like this. Okay, draw the graph. Then write odd functions are symmetric in opposite quadrant or anti-symmetric. Right? Opposite. This is first quadrant and this is third quadrant. Now, they are symmetric in first and third quadrant. Hope all these things are clear.
Yes,
Now let me start with few expansions. Okay, so run expand examples. Run expand. This is very well known to us, but we'll try to understand. Expand e raised to x. That's it. Right here, f of x equal to e raised to x. Find f dash of x, e raised to x. Find f double dash of x, and now so on. If you find any derivative, derivative will be e raised to x only. Okay. Then in front of it, write down f of 0, that is e raised to 0. And what is e raised to 0? 1. F dash of 0, that is e raised to 0, that is equal to 1. F double dash of 0, that is again e raised to 0, that is equal to 1. Right? Na? So all of them, they are equal to 1. Right? If you find remaining derivatives, na, they are also equal to 1 only. Okay, now write down below this. By Maclaurin's theorem, f of x equal to f of 0 plus x f dash of 0 plus x square divided by 2 factorial f double dash of 0, and so on. We know this. Substitute the known values. So f of 0, here it is. Right? What is f of 0? 1 plus x f dash of 0. Here it is. 1 again. X square divided by 2 factorial. Right? F double dash of 0, 1 only. And so on. Okay, so f of x is e raised to x, that is equal to 1 plus x plus x square divided by 2 factorial. What will be the next term? X cube divided by 3 factorial, and so on. Hope everyone is getting this expansion.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
very good. Okay, now write this first. Okay, now see what I'm doing. Now replace x by minus x. So e raised to minus x will be 1 minus x square will be plus x square only. Cube will be negative, right? Raised to fourth will be positive, right? Raised to 5 will be negative, and so on. So alternate plus minus sign is there. And then we are able to find expansion of e raised to minus x. Hope this is also clear.
Yes,
Yes,
sir.
Very good. Okay. Right now,
sir.
next. Yes, in doubt. Okay. We'll go to the next example. Write down. Second example. Expand sine of x. Expand sine of x. So write down f of x equal to sine of x. Find f dash of x, cos of x. F double dash of x minus sine of x. F third derivative minus of cos x. And now so on. We can find remaining derivatives also. If required, we can find remaining derivatives also. So in front of this, write down f of 0, sine of 0. And what is sine of 0? 0. F dash of 0, cos of 0. Right? All these values we can obtain. That according to Maclaurin's theorem, this is Maclaurin's theorem, we know. And so on. Substitute the values. This is 0. This is 1. This is 0. This is minus 1, and so on. Right? The values are known to us. Substitute them and see what we are getting. So f of x is sin x. Like this. So you might have observed that what the next term will be, alternative plus minus sign is there, and we have odd degree terms, odd power terms. Okay, like this. Next is x raised to 9. Next is x raised to 11. And so on. Understood?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
So odd degree terms, odd power terms. Okay. So why odd power terms? Sin x is what type of function?
Odd function.
Right. Odd function. Right. No? Odd function, therefore odd degree terms. Right. And then why we have alternate plus minus sign? Since derivatives are alternative positive negative, na? Sign is decided by the sign of derivative. Understand what I'm saying? Sign of the terms is decided by sign of the derivative. Whereas whether we have odd power terms of x or even power terms, it is decided by whether function is even or odd. Right, now you go to the previous example, e raised to x example. Right, here it is. यहाँ पे है. Right, here we have 1 x square x cube, that is all terms we have, odd as well as even. Why? Since e raised to x is neither even nor odd function, therefore. Getting everyone? E raised to x, this is neither even nor odd function, therefore we have all the terms. Clear? Okay. Now we'll find expansion of few more expansion, and then at the end I'll write around 12 to 13 expansions together. Okay, so right, next, third, let me change the page. Right, expand cos x. I am finding the derivatives. F triple dash of x. Then in front of them, write value at x equal to 0. So use the Maclaurin's theorem. Right, therefore answer is like this. So alternate plus minus sign. All the powers are even degree. Okay, and you might have understood why it is so.
Yes, sir.
Even function. Therefore, in this way we can develop formulae of all the functions. What we can do? We can develop formulae of tan x, then remaining functions also. So what we'll do now, we'll write all the formulas together. Fast, write it, understand it. If any doubt still, if any doubt in whatever we studied still, you ask it to me. Okay, so right, write with me. Standard expansions are. Standard expansions are. Okay, 1 minute. E raised to x. इसको याद रखना है आपको. You have to remember all these expansions. Neither even nor odd function, na? Therefore expansion is like this. So it is having all the terms. then around second, alternate plus minus sign. Whatever written above is true in this case also. It is neither even nor odd function. Okay, next right. Sin x. So see, sine of 0 equal to 0, na? So no any constant term. Constant term of the expansion is decided by value of the function at x equal to 0. Sine of 0 is 0, so no any constant term. So where we have to start? We have to start with the x. And why we are starting with x? Why we are not starting with x square? Since sin x is odd function, therefore we have to start with the odd degree term. Odd function. Next, cos x. Cos of 0 is 1, so we have to start with the 1. Even function. Okay. Next, tan x. So somewhat different, huh? So try to understand it. Odd function, huh? You might know that tan x is odd function. I have written odd over here. Odd function. And remember that in case of tan x, all the terms are positive. All the derivatives are positive, therefore. All the derivatives of tan x, they are positive. Therefore, all the powers are positive. Okay, next right. This we not studied till, but maybe after some time we'll study it. Right out. Sin h. H is for hyperbolic. Sin hyperbolic of x. So expansion is same as sin x, only change is there in the sign of the derivative. Odd function. H is for hyperbolic, huh? Next. Expansion of cos hyperbolic of x is same as cos x. Only all the terms are positive. That is the only change. Alternative plus minus sign. Right to what type of function it is. Let me go to the next page. Simultaneously try to remember it. Okay. to the next page. Log 1 plus x. X minus x square by, it is not 2 factorial, just 2 plus x cube by 3 minus x raised to 4 by 4. So from here, say we want to find expansion of log 1 minus x. What should be done? How we can find log 1 minus x? Anyone? Can anyone tell me how we can find expansion of log 1 minus x if we know the expansion of log 1 plus x? अरे simple compare करो, just
Change of
compare it.
sign.
Replace x by minus x. Everywhere we replace x by minus x. Replace x by minus x, so minus x. Minus x square by 2. All terms are negative. Getting?
Yes, sir.
Okay. Can anyone tell me how we can find expansion of 1 upon 1 plus x using about 10 expansion? Yes.
By differentiation,
Very good. Whose differentiation?
log 1 plus x.
Log 1 plus
Log 1
x.
plus
Correct. Formula number 9. Very good. Very good. Formula number 9. Log 1 plus x. What is the derivative? 1 upon 1 plus x. Differentiate on other side also. Derivative of x 1. Derivative of x square by 2. 2x. 2 will cancel. Next derivative 3x square. 3 will cancel. X square. And now so on. Next, how we can find expansion of 1 upon 1 minus x?
Differentiating 10.
Derivative of 1 log formula number 10, or in formula number 11 you replace minus x, 1 and 7. And last formula. This is binomial expansion. Hope everyone know the binomial expansion of this term. 1 plus nx plus n. I think everyone know all these things very well.
सर 1 upon 1 minus x में सारे टर्म्स नेगेटिव हो गए ना?
नहीं ना, see, I think you are finding derivative of log 1 minus x, na?
Yes.
Derivative is 1 upon 1 minus x. Again 1 minus x will be there. Derivative of 1 minus x, right now?
Yes.
And that will cancel from both the side. Okay?
Yes, sir.
Yes. Right. Note. 3 notes are there. Read on. 1. Constant term of expansion. Constant term, you understand? Na? Constant term means a term which is free from x. So see the formula number 9. No any constant term. We start with the x. Formula number 10, no any constant term. We start with the minus 6. Formula number 11, constant term is 1. Formula number 12, constant term is 1. Formula number 13, constant term is term, right? Whether constant term exists or not, and if it is exist, how to find it? That we are writing in the statement number 1. So down. Constant term of expansion is f of 0, value of the function at x equal to 0. How we can obtain the constant term? F of x at x equal to 0. Okay. Then second,
Sir, can
sign
you
समझते ना
repeat
plus
first point?
yes.
Sir, repeat.
Constant term of the expansion is f of 0, and then remaining things are written on the board. F of 0 equal to f of x at x equal to 0. Okay. Then if function is odd, it contains odd degree terms, odd power terms, sorry. It contains odd power terms. Same is for even, we are not writing them separately. Same is for neither even nor odd function. Okay. Then next, sign of the derivative, whether the term is positive or negative. Sign of the term, it should be written in this way. Sign of the term is decided by sign of the derivative. Sign of the derivative. So whether derivative is positive or negative, वहां से decide होता है. ठीक. चलो आगे बढ़ते हैं. Next rada. We'll go through few examples to understand what we are doing. So rada, expand. Let me start with a simple example. Rada, expand. Examples now. First example. Previous examples, they were to develop the concept, to develop the formulas. So 13 formulas we have now. Okay. अब expand करते हैं. Expand sin x into cos hyperbolic of x up to x raised to 5. थोड़ा सा मैं difficult example ले रहा हूँ. Okay, before we proceed, we'll understand one concept, and I think it will be better to solve this example on the next page. So let me first write the concept here. Okay, so let f of x equal to sin x into cos hyperbolic of x. Tell me what type of sin x function is even function or odd function? Odd function. Okay, and what about cos hyperbolic of x? Like the cos x only. Cos x is a even function. And what is even into odd? What is multiplication of even into odd function? What is resultant?
Odd function.
Yes, it is odd function. Okay. Those who don't know, you can write this inside. बस आप नीचे लिख के रख सकते हैं, right? So even into even function, resultant will be even function. Even into odd function, resultant will be odd. Odd into even function, resultant will be odd. Whereas what is odd into odd function? Resultant
Even
is
function.
a even function. This is for the multiplication, right? Same is true for the division also. Even function divided by even function. Resultant is even function. Even function divided by odd function. All these things are required in next topic, next unit. So you just write them and understand them. Odd function divided by even function. So odd. And odd function divided by odd function, resultant is a even function. इसको याद रखना है आपको. Right. So f of x is odd function, which is multiplication of odd and even function. Now go to the function. Okay. So what the f of x will have? F of x will have, yes, odd degree terms or even degree terms? अरे odd function है ना?
Odd degree term.
Will have odd power terms. This will help us to check whether we are on the right track or not while solving the example. So I'll go to the next page and I'll use the whole page. Okay. So 1 minute only. It should be like this. Okay. So let me change the page. I'll go to the next page. You can give some time to me, understand first, and afterwards you can write. Or those who are confident, they can start writing with me also, no any problem. So it is like this: y equal to or f of x equal to 1 and same, meaning it's same only. Sin x into cos hyperbolic of x. Expansion of sin x is known to us. What is the expansion of sin x? X minus x cube divided by 3 factorial plus x raised to 5 divided by 5 factorial. Okay, probably next term is not required. But since it is first example and till we don't know the concept, so let me write the next term also. Our aim is to get expansion of x raised to 5. Though I have written x raised to 7 terms, since don't know if there is 1 upon x, x will cancel. Therefore, what about cos hyperbolic of x? 1 plus x square divided by 2 factorial plus x raised to 4 by 4 factorial plus x raised to 6 by 6 factorial. Right. Now, while solving example, we don't want these factorials. So let me simplify it. So it is like this. X minus x cube divided by 6, x raised to 5 divided by 120 plus x raised to 7 by, I don't know what the 7 factorial is, and it will be not required. So I'm writing it as a 7 factorial only. Those who know the 7 factorial, they can write its answer. 1 plus x square divided by 2 plus x raised to 4 divided by 4 factorial plus x raised to 6 divided by 5 factorial is 120. So 720. Okay. Now see what I am doing. I'll multiply the second bracket by x. And while multiplying, what I have to do? Considering. Okay, this is very important. Considering terms up to x raised to 5 only. Since it is asked to find expansion of x raised to 5, therefore. So it will be like this, equal to, I am multiplying second bracket by x. So 1 into x, x square divided by 2 into x cube divided by 2. Next is x raised to 5 divided by 24. What about the next term? X raised to 7, not required. This when we multiply by x. We got this answer when we multiply by x. Now let me multiply by minus x cube by 6. Minus sign outside. Now I'll multiply by x cube by 6. X cube by 6 into 1. X cube by 6. X cube by 6 into x square by 2. So x raised to 5 divided by 12. Right. Next term will be x raised to 7 term, which is not required. RNA sabko samajh mein? Everyone is getting this?
Yes, sir.
Yes, sir.
Very good, very good.
Yes,
Now
sir.
I'll multiply. Okay, I'll multiply by x raised to 5 by 120 to the next bracket. So since we have plus sign over here, I'll write plus over here. Okay. Then x raised to 5 divided by 120 into 1. So x raised to 5 divided by 120. Next is x raised to 5 x square, x raised to 7, not required. Okay, plus. Now what about the remaining term? Next is x raised to 7, x raised to 7 into 1 will be x raised to 7, which is not required. Okay, so we have to terminate the expansion over here. And then we have to add the like power terms. That's it. Okay, so the like power terms are, now here you can use the calci to get the required answer. So x plus x cube divided by 2 minus x cube divided by 6. Right, only two terms are there in x cube. X raised to 5, x raised to 5 divided by 24. Right, minus x raised to 5 divided by 12 plus x raised to 5 divided by 120. And then higher reading terms. Now you can find the answer by calci. Yes, do it yourself. Chalo dekho aap kya aa raha hai. Check it and understand it very well. Is it visible to everyone?
Yes, sir.
Those who are using mobile, those who are using laptop, PC or any other device, hope it is visible to everyone. Hope the
Yes,
size
sir.
of yes. Yes, in doubt. Okay, see what the answer is. So hope answer is like this. X plus x cube by 3 minus x raised to 5 by 30. Check this.
Yes, sir.
Yes, this is the required expansion. Okay. I'm expecting that you should be able to solve the next example. We'll go to the next page and try to solve the next example. चलो सॉल्व करते हैं, नेक्स्ट पेज पे जाते हैं. Have you written the answer? Can I go to the next
Yes,
page?
sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, chalo. Page number 6. Next example, expand e raised to x cos x up to x raised to 4. Yes, you try it. 2 minutes are there for you. Expansion of e raised to x is known to us. Yes, expand it. Do it yourself and tell me the final answer first. Yes, what the answer is? It is like this, multiply by 1. 1 minus x square by 2 plus x raised to 4 by 24. I forget to write it here, considering terms up to x raised to 4 only. Yeah, we have to consider terms up to x raised to 4 only. Okay. Next is plus, now multiply by x minus x cube by 2 higher degree terms, plus multiply by x square by 2. Achha, better to change the color so that you'll understand it. square by 2. Next is plus x cube by 6. Next is okay. Simplify everything and tell me what the answer is.
Excuse me, sir.
Haha.
Sir, I got the answer. It's 1
Ah.
plus x minus x cube by 3 minus x4 upon 6 plus till infinity.
Absolutely. Very good. Very good. This is the answer, no doubt. Y equal to 1 plus x minus x cube by 3 minus x raised to 4 by 6. Just you have to take the same power terms together. X square terms together, x cube terms together, like this. X square term get cancelled. See, here we have minus x square by 2 and here we have plus x square by 2. That will get cancelled. Hope everyone is getting this answer. Let me go to the next page.
Yes, sir.
If anything is remaining, na, these whatever the videos, we are recording the video as well as these notes, they will be uploaded on the Google Classroom on regular basis. Okay, so they are available on the Google Classroom. So if any particular part is missing, you can copy it from there. But again, I am suggesting be careful, huh? Since you are not in front of us, you may think that okay, I will write it afterwards. Okay, so don't do like this. Write with me. That will see, writing it afterwards, it is very difficult. And if you want to write it, you can write it second time, na? First time you write with me, with everyone during the class only, huh? Make habit of writing, huh? I may ask you to show the notebook at that time only, huh? So keep the notebook with you. Already we have decided that we should have a separate notebook for mathematics. Okay, Sradhan, expand. Next, next page, page number 7. Sradhan, expand. Root of 1 plus sine x up to x raised to 5. Yes, anyone? How we can remove the root?
Sir,
Sir,
from
squaring
sin
of
x
both
to
sides.
from
But
sin
then
x,
in that case we'll get y square, na? Our aim is to find y, na?
सर हम sin x को
Yes,
ना
to
2
half.
sin x by 2 cos x by 2 लिख देंगे
Yes.
Very
और
good,
1
very
को
good.
sin square x by 2 plus cos square x by 2 लिख देंगे.
Very good,
इससे वो sin
absolutely.
x by 2 plus cos x by 2 का whole square हो जाएगा.
Absolutely, absolutely. Since sine square theta plus cos square theta equal to 1, na? Right, so tell me what will be sine square x by 2 plus cos square x by 2? 1 only. I replace theta by x by 2. Okay, this is the first formula that I am using. And second formula, I will use this formula. What is sine 2 theta? 2 sine theta cos theta, na? Right, and in both the formulas, I am replacing theta by x by 2. Okay, so sine x will be equal to 2 sine x by 2 cos x by 2. Hope everyone is getting these trigonometric formulas. Okay, let me use them. So we have y equal to, I'll use them in the y, root of 1 is sine square x by 2 plus cos square x by 2, isn't it? Plus sine x is 2 sine x by 2 cos x by 2. Hope everyone is getting this. That is equal to This is like this: a square plus b square plus 2ab, isn't it? So it is a plus b square. Okay, so it is sin x by 2 plus cos x by 2 whole square. Right, square and square root will cancel. So y equal to sin x by 2 plus cos x by 2. And we know the expansion of sin x. We know the expansion of cos x. Right, so I'll write them once again so that there will be no any confusion and you will start remembering them. Using sin x equal to x minus x cube divided by 3 factorial, x raised to 5 by 5 factorial, and so on. Cos x equal to 1. Right, so here we will replace x by 2. X is to be replaced by x by 2 in 2 formulas. Huh? I think you might have understood it. So y equal to x by 2, x by 2 cube, x by 2 raised to 5, and so on, plus now expansion of cos 1 x by 2 square, x by 2 raised to 4. Yes, now simplified and arranging in ascending order. So first do it. Check your answer. I have the answer, therefore I have written it directly. Huh? You just see whether you are able to get this answer or not. This is the answer. I think you have next lecture, na?
Yes, sir.
Let me take the attendance. 1 minute only. I can take attendance directly, huh?